Hi, I'm Temitope Adeniji, and you are welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. In the past years, I've realized that a lot of students struggle with understanding organic chemistry. And in fact, it is a worldwide issue with most science students. But in this video, I'm going to reveal the strategy to understanding organic chemistry to you step by step. So don't skip any of the lessons. In the previous episode of the Introduction to Organic Chemistry, we discussed all this, but today we are going to focus on the classification of organic compounds, hydrocarbons and its type, as well as the types of organic formula. Classification of organic compounds. Organic compound can be classified into two main categories, namely, we have the hydrocarbon, and secondly, we have the functional group. What are hydrocarbons? Hydrocarbons are the class of organic compounds that contain carbon and hydrogen atom only, that is, carbon and hydrogen atom as its constituent elements. Every hydrocarbon contains carbon and hydrogen. As their constituent elements. So the hydrocarbon can be classified further into, we have the aliphatic hydrocarbon, alicyclic hydrocarbon, and aromatic hydrocarbon. The aliphatic hydrocarbon are also referred to as the open chain hydrocarbon. The alicyclic hydrocarbons are the closed chain hydrocarbon. They are in their ring form, ring structure, while the aromatic hydrocarbon contains a benzenoid structure. From this flowchart, we can consider the classification of hydrocarbons further. Here we have aliphatic hydrocarbons. The aliphatic hydrocarbons are also the open chain hydrocarbon. That is, it can be a straight chain or branch chain. When we consider the uniqueness of carbon, we talk about identifying a straight chain and branch chain. So a very good example of the straight chain hydrocarbon is this straight chain. While the branch chain hydrocarbon, note that we have equal number of carbon atoms there. So we can introduce the hydrogen atoms there. Remember, carbon is tetravalent. So I have 4 bonds around carbon. Okay, while in the second one I have this. Now this branch chain hydrocarbon, this is branched chain, and this is the straight chain hydrocarbon. Okay, this is said to be straight chain because we have the carbon atom in the pipe in a single direction, while this is regarded as branch chain because the carbon atoms are in different directions. So they are regarded as aliphatic hydrocarbon. The next one is the alicyclic hydrocarbon. Alicyclic hydrocarbon, they are also regarded as closed chain hydrocarbon because they are in their ring form. Are homocyclic in nature, that is, we have just carbon atom in the ring structure. So when it is only carbon atom in the ring structure, we say it is homocyclic hydrocarbon or homocyclic compound. Heterocyclic compounds are not hydrocarbons because when we have heterocyclic compound, we have atom other than carbon in the ring structure. So we cannot refer to heterocyclic compound as hydrocarbon. So this is not hydrocarbon. The next one is the aromatic hydrocarbon. The aromatic hydrocarbon contains at least a benzene structure. That's why I have it as a benzenoid structure. And benzene is a hydrocarbon compound. The non-benzenoid structure are said to be non-hydrocarbon. They are not hydrocarbon because if they are non-benzenoid in structure, that implies that they contain atom other than carbon in the aromatic structure. An example of the homocyclic hydrocarbon is the cyclopropane right here. We have hydrogen, 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 cyclopropane. Remember I said we are still going to consider the rules to writing IUPAC nomenclature. Why the heterocyclic compound, which is not hydrocarbon? Because heterocyclic compound contains atom other than carbon in the ring structure. We can have something of this kind. This is hetero because we have oxygen in between the carbon ring. Also, we have the aromatic hydrocarbon. Under the aromatic hydrocarbon, we have the benzenoid structure. The non-benzenoid structure contains atom other than carbon and hydrogen. So we cannot refer to this as hydrocarbon. Okay? So this is not hydrocarbon. So the benzenoid structure, a very good example of this is benzene compound. We have alternating double, single, double bond. And in a benzene compound, we have 6 carbon atoms. Just carbon and hydrogen. That's what actually makes it hydrocarbon. So this is the benzene compound. The non-benzenoid structure, a very good example is the pyridine, which has nitrogen as the heteroatom, that is the atom that exists in the structure other than carbon and hydrogen, which is what nitrogen is the heteroatom. We have the pyridine. It has similar structure as we have in the case of the benzene, but one of the carbon has been replaced with what? Nitrogen. So since we have atom other than carbon and hydrogen, we cannot say this compound is hydrocarbon. It has atom other than carbon and hydrogen. So this is pyridine. Pyridine compound. Types of hydrocarbon. There are 2 basic types of hydrocarbon. We have the saturated hydrocarbon, and the second one is the unsaturated hydrocarbon. Saturated hydrocarbon are those hydrocarbons that contains carbon to carbon single bond. We have just carbon to carbon single bond, and this is observed in the alkane homologous series. Recall that the general formula for the alkane series is CN H2N plus 2, and the first member of the series is what? That's right, the methane. The methane has the molecular formula CH4. Other members can be deduced from the formula monkey eats plenty banana. Monkey, the first, which is met, eats plenty, probe, banana. That's the boots. Okay? So since we are dealing with the alkane series, we have the first member when we had ANE, methane, ethane, propane, butane. Recall from the characteristics of homologous series, we said the successive members differs from the next by a CH2 group or relative molecular mass unit of 14. So we have the methane as CH4. That implies that when CH2 group is added to CH4, what do we have? Okay, that's right. We have C2H6. For the propane, when CH2 group is added to the C2H6, we have C3H8, add CH2, C4H10. Okay, this is how we can deduce the molecular formula of every members by adding the CH2 group. So this is methane, ethane, propane, and butane. The prefix for other members of the series are derived from the Greek word, okay, for numbering. We have the fifth one being pents, sixth eggs, seventh eggs, eighth ox, 9 non, and 10 is given as what? Dec. Okay? So we had ANE, it becomes pentane, hexane, heptane, octane, nonane, and decane. We have a question right here. What will be the molecular formula of and 9th member of alkane series? I would like you to pause the video and attempt the question. All right. Let's do it together. The 5th member of the alkane series, recall, we have the general formula CnH2n plus 2. Okay? So the 5th member, N equals 5. So when N is 5, we have C5H 2 times 5, 10 plus 2. That's 12. So the 5th member is C5H12, which is pentane. The next member of the alkane is hexane, though we were told to find the 9th member. Okay, 9th member, N equals 9. So C9, 2 times 9, that's 18 plus 2. That's 20. Okay, so the molecular formula for nonane is C9H20. So that's the solution to the question. Make sense? Moving on to the next type of hydrocarbon, which is unsaturated hydrocarbon. Unsaturated hydrocarbons are hydrocarbons that contains carbon to carbon multiple bond. It can be carbon to carbon double bond. We can have it as carbon to carbon triple bond. They are said to be unsaturated hydrocarbon. This is observed in the following series. We have it in the alkene series. In the alkenes, it is observed in the alkynes, as well as the aromatic hydrocarbon. Okay, so the alkenes contains carbon to carbon double bond. The alkynes contains carbon to carbon triple bond, while the aromatic hydrocarbon, a very good example is the benzene structure, which I said has alternating double, single, double, single, double bond. The alkenes has the general formula CnH2n. The alkynes has the general formula CnH2n minus 2, while the aromatic structure exhibits the general formula CnH2n minus 6m. Recall that the N denotes the number of carbon atoms in the formula, while here the M denotes the number of fused ring. Fused ring. Okay, like in the case of benzene, the ring is not fused. When we get to the naphthalene, we have the fused benzene ring 2. So therefore M will be 2 in the case of naphthalene. Anthracene, M will be equal to 3. So let's come back to this. The first member of the alkene series has the molecular formula C2H4. Okay, and the IUPAC name is ethene, which is also referred to as ethylene. While the first member of the alkyne series has the molecular formula C2H2. Okay, in place of N we have 2, C2, then H2N. That's 2 times 2, 4 minus 2. That is what? 2. This is the ethyne. It is also referred to as acetylene. Okay, so the benzene ring has what? The number of carbon to be what? That's right, 6. Okay, so we have benzene C6H, 2 times 6, that's 12. 12 minus the number of fused ring is just what? We have just one ring here. So 6 times 1, that is 6. So 12 minus 6 will give us 6. So we have benzene to be 6H6. Okay, this is benzene. Makes sense? So we can see that the first member of the alkene series is ethene. Then what will be the second member of the alkene series? That's right, propene. The third member will be butene. The alkyne series, the first member is what? The ethyne. The second member is propyne. That's correct. The simplest aromatic compound is the benzene right here. Okay, I would like you to consider the general formula for the alkenes and alkynes in answering this question. Write the molecular formula and name of the sixth member of the alkenes and alkynes. Okay, so you can pause the video while you answer the question. All right, let's take the solution together. Okay, the sixth member of the alkene will have what? The value of N to be 7. Okay, so the sixth member will be what? C7H what? 2 times 7, 14. C7H14, not C6H12. So you have to correct that. This is ethene. Okay, X, that's 7. While the next one, the alkyne, N equals what? 7 as well, not 6. Okay, you know I told you the first member for the alkyne is C2H2. So take good note of that. Okay, so we have C7H, 2 times 7, that's 14 minus 2. Okay, that's 12. This is ethyne. So the sixth member of the alkene is ethene, while the sixth member of the alkyne is ethyne. Okay, makes sense? Types of organic formula. Note that Organic compound can be expressed in different forms or formula, which include, we have the molecular formula, condensed formula, structural formula, we also have the display formula, which is also known as the stretched formula. Display formula. And the last one is the skeletal formula. Skeletal formula. So for example, I'm going to take the forms or formula of the fourth member of our alkane series. Let's start with the molecular formula. The fourth member is butane with the molecular formula C4H10. That's correct. So the condensed formula is written as CH3, CH2, CH2, CH3. Or it may be written as CH3, open bracket, CH2 to CH3. Okay? While the structural formula is written in a similar form as we have in the case of condensed formula, CH3, CH2, CH2, CH3. The display formula is expressed this way. We have to show the carbon skeleton. In the display formula, we have hydrogen, 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 hydrogen. Okay, that's the display formula for this butane, while the skeletal formula is written in this form. So each point right here indicates carbon atom 2, 3, and 4. That's the skeletal formula for the butane. So I would like you to attempt the forms or formula for the sixth member of the alkane. The sixth member of the alkane is what? Okay, that's right, that's hexane. So pause the video and attempt that for the sixth member of the alkanes. All right, let's answer the question together. The sixth member of the alkane will have the molecular formula C6H what? That's right, C6H14. Okay, so the condensed formula is written in this form: CH3, CH2, 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 CH3. Okay, we can also write it as CH3, open bracket, CH2, 1, 2, 3, 4, subscript 4, CH3. Okay, now the structural formula is written in a similar way as we have in the case of condensed structure: CH3, CH2, 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 CH3. Okay, 1, 2, 3, 4, 5, 6. The display formula for the hexane right here is written as carbon, 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 carbon. Okay, so I have saturation with hydrogen, 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 hydrogen all through. So we have hydrogen all through the carbon. Okay, to saturate the carbon atom, remember the tetravalency of carbon. So that is the display formula for the hexane. While the skeletal formula is written in this form: 1, 2, 3, 4. Let's count. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. We have one more, and we have 6 carbon. Okay, makes sense? Similarly, we can consider the forms and formula for the alkene series. Alkenes. So let's take, for example, the second member of the alkene with the molecular formula C3H6, which is what? The propene. Okay, that's the molecular formula for propene. The condensed formula is CH3CH2. Okay, while the structural formula is written as CH3 CH double bond CH2. Can you see the reason why I have to express CH right here? So we have double bond in between the carbon atom at the extreme end there. So the display formula is written as, you show the carbon skeleton, okay, with single bond connection at first. Since we are dealing with alkene, we have a double bond right there. So hydrogen count 1, 2, 3, 4. We have 4 bonds around carbon. Hydrogen count 1, 2, 3, 4. We have 4 bonds around carbon. Hydrogen. So this is the display or stretch formula for the propane. Lastly, we have the skeletal formula. Be careful with the way you write the skeletal formula right here. So the carbon, and carbon. So we need to express that it is unsaturated hydrocarbon with a double bond. We have this. Okay. Moving on to the next, we have different forms and formula for the alkyne homologous series. The alkynes, with the general formula CnH2n-2. So the second member of the series is C3H. 3 times 2, we have 6 minus 2. That is 4. Okay, this is propane. The condensed formula for the propane is written as CH3C. We are not going to express the triple bond, but I will just have it as CH. Okay, while the structural formula is written as CH3 single bond C triple bond CH. Okay, the display formula is expressed as carbon with a triple bond in between. We have hydrogen. So if you check around the carbon, we have 4 bonds around each of the carbon there. The skeletal structure is written this way. So here we have carbon, so triple bond. Okay, so that's the skeletal structure for the propane. So we have the CYK3. Write the molecular, condensed, structural, display, and skeletal formula for the fourth member of the alkenes and alkynes respectively. Note that for the fourth member of these two homologous series, N will be equal to 5. I would like you to express the formula for the fourth member of these two series. You can pause the video while you answer the question. Alright, here is the solution to the CYK3. We have the alkene member, which is the fourth member of the series, is the pentene, which has this condensed formula, structural formula, display formula, and the skeletal formula. And the fourth member of the alkyne is the pentane with the respective formula. So kindly go through the table right here so that you can actually compare it with what you've gotten as an answer. I hope with everything we've discussed in this episode, you're already feeling comfortable with organic chemistry. Kindly click the subscribe button and share with your friends right now. You can also follow and like my Facebook page. Thanks for watching.